Okay, so hello everyone, and welcome to another EESSI Happy Hour session. That is every Monday between 2 and 3 p.m. Today we are still in the topic series of building on top of EESSI, and the current session is about how we build software in EESSI. I would, before starting, remind you that this session is being recorded. And at the end of the session, we will stop the recording in case anyone feels more comfortable to share anything related to EESSI. Today, as said, our session is how we build on top of EESSI. To build on top of EESSI or to build software in EESSI, we use the easycontainer.sh script. This has been explained earlier, and as far as I remember, it was the second session in the EESSI Happy Hour sessions in the topic series of getting access to EESSI. So what the easycontainer.sh script does is that it gives us or provides us access to EESSI using a container. There, no admin privileges are required. All what is required is to have Singularity version 3.7.x or Obtainer version 1.0.0 and above. That allows us to get access to EESSI. For more information about the EESSI container that we covered earlier, you can check the Happy Hour previous sessions under EESSI Docs Training Events 2025. We will be getting to this again in the live demo. After getting access to EESSI, we will be using the EESSI Extend module. The EESSI Extend module was covered in the previous Happy Hour session. And what the EESSI Extend module does is basically it loads the EESSI Build framework. In addition, it sets some variables which are essential for some variables in EESSI Build which are essential for building software in EESSI. We will also have a quick look for them in the live demo. But so why is building inside a container important for us in EESSI? Using the container gives us or guarantees us consistent builds, which we will see in the live demo. It also ensures reproducibility. It gives better isolation from the host environment. And finally, which is important for us, is it enables write access to the EESSI CVMFS repository through the overlay.fs, or not the repository, in fact, which is the CVMFS software layer that we offer. So why wasting more time? Let's jump into the live demo and see what I have to show you today. So this is our famous EESSI Happy Hour VM, and it's a minimal VM. Basically, it uses 2 GB memory and it has 20 GB disk, and it is LS CPU. CPU grep minus I as well as just to make sure. Yes, so it is an Intel CPU with a Haswell family. So what I will do in the first run is I will load. I already on this VM have access to EESSI through the native installation. So if I do ls/cbmfs software.easy.io, I will see that I already have access. So in the first run, I will try to load the EESSI build module, EESSI extend module, after sourcing the init script to get access to EESSI. And I will try to build a software package. So we will see step by step. First, I will source/cvmfs software versions 2023.06 init bash. We already have covered this in the first session we had to get access to EESSI. And what I can see here is that it has detected the Haswell CPU microarchitecture I have. It has also detected that there are no GPUs on my system, and it gave me access to the Haswell software stack provided by EESSI. What I will do next is I will load the EESSI module, but first I will also show you a quick look for the options we saw previously in the previous EESSI Happy Hour session. So if I do ml show EESSI extend, I will see that when I load the EESSI extend module, I basically have several options where to install the software I'm building. I can either install it in the user space, in a project space, a site space, or use the CVMFS install, which I mentioned earlier, which we get access to when we use the container. And that is one of the differences I will show in the second run. So for now, I will simply load ml EESSI extend. And again, I will show you EB minus minus. Now, as I said, it already loaded the EESSI build framework. So I will show EB minus minus show config to show you some of the parameters set or that we use while building software. So again, this was explained in previous EESSI Happy Hour session. So for example, we filter environmental variables such as the LD library path, and we filter some of the dependencies like binutils, bizip2, extras like libtool, M4 auto tools. Those are automatically used from the compat layer of EESSI. So instead of building them, we use them from the compat layer. And as you see here, by default, because I didn't set any variables, it chooses to install the software that we built in my home directory. So what I will do next is try to export the install path just to point it to another directory where I want to install the software I want to build. Plus, I won't show you that. Today's software package I will try to tackle is called Glue. There is no reason I chose that, but because it can pinpoint something very important in why we build software in a container. So Glue is already available in EESSI. So if I do ml avail Glue, I will see that it is available in EESSI. But what I will do is eb minus s glue, and I will choose the exact same package which already exists in EESSI, and I will try to build it. So eb minus r. If I do this, it will automatically tell me that it already exists, so no need to build it. But if I add a minus f to force build it, I will see that it will try to fetch it, check the checksums, ensure everything, and try to build it. What I assume is it will work. And so why are we running this? But you will see what's next. So it shouldn't take long, even on this minimal. It fails. If I have a quick look in this, so if I check the log, I will see that if I focus on the last few lines, I will see that it is trying to link against /user/lib64, which basically it is trying to link from libraries using the host, not the compat layer. And then it fails because it tries to use the glibc used in LLVM, which is from EESSI. So using glibc from EESSI and glibc from the host definitely will not work. And that is why we always use the EESSI container, because we then get and guarantee a consistent build. We guarantee that it is linking against the compat layer from EESSI. So now I will go to the second run, load the EESSI container, and try to build exactly the same package. So this is another happy hour session on the VM. And what I will do is go to the software layer scripts to get access to the EESSI container .sh script. We clone the software layer script from EESSI. Again, you can check previous sessions, webinar sessions, or the EESSI Happy Hour sessions. And now I will run the EESSI container. Before doing that, I will show you some options in the EESSI container also, which we are going to use now. So as you see in the help, there is first the -A option, which I will use to get read-write access to the CVMFS, which we need when we build software in EESSI. Next, I will optionally be using the -B option to add some extra path. The -I, which stands for host injections, and the -N for NVIDIA mode are needed when I want to build software in EESSI, or when we want to build software in EESSI and use GPUs. And the -O option is also an overlay, which gives me access to the read-write CVMFS, which I'm going to be showing. So for now, I will be trying to run this command, which basically is what I explained. It is the EESSI container script, adding -A read-write to give access. And I see here the -C. What the -C is just I'm providing the default image so that I won't lose time fetching it from the internet on this minimal VM. And maybe it's also better to show you the -C option, which basically you provide whatever image you want. I will be using the default one, which we use in EESSI. So with this and the -B, I'm just using my old home to point and the -V option to show verbose so that I can see what really is happening. So if I run this, I will say it's pretty fast because it didn't download the image. It just used the image I provided. I also see the real singularity command it's using. So it's using the -O COW and showing how I should theoretically now get access, a read-write access to the CVMFS from EESSI. So if I do a def -HT, I can see two things. I can see two CVMFS, software.easy.io. The first is CVMFS read-only, and the second is CVMFS software.easy.io. Up till now, basically this is the additional thing I got by using the options. Next, as I did earlier, I will load the EESSI Extend module. While loading the EESSI Extend module, what I showed earlier is that there is an option which I can set, which is called EESSI CVMFS installed variable. If I set that variable, then I can get access to the CVMFS by default while loading the EESSI Extend module. So that my software installations will reside on the CVMFS overlay I'm using. That doesn't mean at all that I will officially be building on top of CVMFS for EESSI. That is only in the VM I'm running. So if I export this variable and then module load EESSI extend. So I should first also try to initialize EESSI, which I forgot. Software versions init hash. Again, it has detected what we have seen earlier, a Haswell, no GPU, offered me the proper optimized software stack from EESSI. And then if I now again export and try to load the EESSI extend, I will show you the difference. EB -- show config with the last option. And this is the minimal VM, so it could be taking some time, hopefully not too much. Yes. So what you see here is now, I'm installing software in CVMFS software.easy.io versions. Again, this is not real. This is just on my VM. It is not on EESSI software stack. So what I do next is exactly what I've done earlier. So I will again show you that glue is available, ml avail glue. It is available here, EB-S to search for all easy configs related to glue, and EB-R with the -F option to force build this package because it already exists in easy. So if I do this now, hopefully it won't take long on this VM, it shouldn't. Yeah, so it's fetching the glue packages, source packages. It's taking a bit time, hopefully not. So it's loading the dependencies and it's now trying to build what failed earlier without the container. It shouldn't take long, like I'll give it, yes. So as you see, the difference between earlier and now, it has successfully built the module and set it in CVMFS. And to check this, I will show you the date of this package. There is an additional -S which has been added. Yes, so as you see, it is built also almost a minute ago, which shows that it really is writing on CVMFS / software.easy.io, which is offered to me as an overlay in my container. And here we can see that by building this, we get a more consistent builds, which are specifically linked against our compat layer from Easy. This doesn't mean that building without the container will always fail, but it means that for us, since we ship software, we need to make sure that this is built against our compat layer and not picking up something from the host itself. Going back to the presentation. So what we've seen today is building software. I built the glue package for only single architecture. But we said earlier that we do this for 14 different architectures. So this process is taken care by the bot. So the EasyBot, this is the second time we mentioned the EasyBot. The EasyBot takes care of automating the build process. It doesn't just do that, it does much more. But for now, I will just say this and hope that you stay tuned for further sessions to get more information of what the bot does and how it takes care of providing the package that we build and ship it to the Easy Stack. For more information about Easy, different project repositories, you can check the github.com/easy. There you will find more information about the bot, the Easy software repositories. And for today, this is what I wanted to present. Before we close the session, today we have a special guest from UIB. They have a special use case for Easy and they want to present it. Maybe we can give more ideas. Maybe we can share what they did. So I will hand over to Eric. Eric, can you hear us and can you share your screen?
Yeah, thank you, Richard. So if I press this button, I have requested to be able to share. I don't know if you have to.
So first, there is no need to stop the recording, right, Eric?
No, that's fine.
Okay.
Yeah, and then I can share. Yeah, so I am Eirik. I work at the University of Bergen's
Did
group
you
called.
sorry, did you share your screen, Eric?
I think I do. You're saying
Yes,
you
can
are
see.
screen sharing. You can see? Yeah.
Yep.
Okay, excellent. Yeah. So I work at the Sensitive Forskningsdata and Lab IT is the group that I primarily work with a service called SAFE, which is a service we provide to people working with sensitive data. So a secure processing environment for people to work on black or red data as we define them in the University of Bergen. And through some workshopping and help from Richard, we have now set up a private Stratum 1 running at UIB that is connected to SAFE. So hopefully this question mark behind the true can be removed very soon. So SAFE, just a little bit about background about what SAFE is. It's in SAFE, you get your own server that is default completely isolated from other services and the internet. There are a small amount of exceptions like network attached storage areas and some software packages coming from a system called SSM. And that protection is built up by layers of firewalls and primarily three, which is one on the server itself, one internally inside SAFE, and one on the outside of SAFE, but at the UIB layer. So how do we get then EESSI inside SAFE? So a decision was made that we could not trust the public Stratum 1s that are available, and we cannot use the public Stratum 1s. So we take our Linux box and we install private Stratum 1 on it, which is a replicator for public Stratum 1 that we are in control of and that runs inside the UIB infrastructure. So that private Stratum 1 blocks all connections by default. So anything that tries to talk to it, the connections will be dropped. We then open from very specific server that needs access. So if a research group wants to use EESSI inside SAFE, they would send us a request and we could open that from that private Stratum 1. And that would give them access to talk to that private Stratum 1. But there is also the CVFMS FMS client. The installation of that is a little bit tricky inside SAFE as well. So we decided to mirror the repository that exists and put that on our own repository at UIB, which is available, which is one of the exceptions we have available inside SAFE, and configure the client to only use the private Stratum 1. This is a short diagram showing how it's set up and how it's supposed to work, or how it is working. So we do sync on the private Stratum 1, we sync the repository from a public one, so we can keep up-to-date software when we need. Currently, I've set that up as a cron job, but I am in the process of doing a risk analysis of whether or not I can keep that open, or if I have to do this on demand or at specific times. This is to prevent the firewall from being opened to that public Stratum 1 at all times. That would be the risk assessment that I will be doing on that. And then from that private Stratum 1, we can stream the repositories inside the zone SAFE to a specific SAFE server. The SAFE zone then has its own firewall layer, which then would require openings for the private Stratum 1 to be able to receive requests from that. And since the private Stratum 1 is a read-only repository, the only possibility you can do from inside SAFE is to read files such that you cannot take data out of your secure processing environment in this setup, which is one of the most important things we are trying to control within a secure processing environment, is that people should not be able to take out data unless it's a real necessity and a real use case, and that the data holder and has approved of that, and the system owner. So currently we are testing this on 3 different Linux servers inside SAFE. One of them is a normal server, and the 2 others that there has been installed on are for HPC process that we are working on within SAFE. So one of the compute nodes and one of the login nodes also have this openings and this clients installed on them. What I need to continue to do is to look further into host injections to be able to support GPU. and figure out a way to make this work on Windows servers inside Safe. VSL has been problematic and has some problems within Safe that is hard to alleviate, and also has an issue supporting GPU loads while you have VSL. There are some security concerns as well, but I'm working on figuring out how I can support this. And I also need to streamline the client setup and configurations for Safe, because currently this is a manual thing. It's in go in and modify the configuration files to only use the private Stratum one. It's currently a manual job, and I want that to be automated. That's pretty much what I had to share. And if anyone has any questions, please feel free.
Thank you very much, Eric. So, and thank you for sharing the presentation, and thank you for sharing how you have managed to use a specific use case of easy and setting Stratum 1 and within an environment that is pretty much closed from outside and totally isolated. From our colleagues in Easy, if you have any suggestions for Eric to further enhance the solution or comments, feel free. Yes, Kenneth?
One idea or one question is how interesting would it be for you to figure out what's actually being used from Easy? So how often Easy is being used, what software is being used from there. Is that something you will be interested
Mm-hmm.
in to gather that information anonymously, of course?
Mm-hmm. I could definitely see a benefit of doing that. Well, if I try to look at the whole of it, that means that maybe we could, if we know that inside our specific use case and inside the field that mostly use Safe, which is primarily health and bioinformatics and people working closely to what is considered sensitive data, we might be able to strip down the private Stratum one and make it a lot smaller, which I see as a big benefit from the infra perspective of it. Other than that, I am not a very scientific software person per se. I am an infrastructure person who tries to build secure processing environments for people. So how they use it and what they use it for is might be out of the scope of what I can feel I can benefit into. But certainly it could be interesting to know specifically for the making the repository as small as possible, I guess.
That that could help, but that's maybe not the only use case for knowing what people are using. If you have a better view of what tools people are actually using, you could
Mhm.
maybe focus on those to improve them, double check things, or let people know that there's other tools out there that actually do a better job than the ones they're
Mhm.
currently using. So there's a lot of stuff you could do, but by having a good view on what software is
Mhm.
actually being used.
Yeah,
Um,
uh, definitely. But I will most likely then bother Richard if I have questions regarding this and rely on the expertise that I already have quite close to me. But I completely understand your perspective of it, and it would be, of course, helpful for our group as well to understand how to optimize the solution for our users.
the reason I'm asking is because having a private Stratum 1 mirror actually helps. You actually have the data in some form in the
Mhm.
logs of the Stratum 1, or if you're using proxies in between on the proxies. So just by analyzing the access logs, you could actually tell what was used in a certain time window and in a
Mhm.
totally anonymous way because there's no user information about how who was pulling in those software installations. So that's an interesting aspect of having a private mirror server. And everything
Yeah,
would
yeah,
be local to your system. So yeah.
yeah, yeah, absolutely. that would that's a very good point, and we are setting up logs for this, and we will probably store those logs somewhere, so we can once they start building up, we can start maybe analyzing them. As I mentioned, currently it's a very small number of installations right now, and not really a lot of real users on them. But at some point, this would be data that could be very valuable for safe to analyze. Thank you.
Just one thing before we can take Thomas's comment also. We also discussed if the possibility of building specific softwares on top of Easy. So maybe that's another step after they get their tests running, we will have to look into. So some specific dedicated software, maybe some licensed software to look into. But in any case, Eric, if you have any question concerning Easy and the usage, feel free to join any of the EESSI Happy Hour sessions, the Slack channel, and post your questions, and we will see how we can further help you.
Thank you.
Yes, Thomas?
Yes, the accesses on the Stratum 1, would you see the software that is actually accessed there, or the sort of the only the so the parts of a file in the how the CMFS stores the information internally?
Is the question for Eric or for Kenneth?
More for Kenneth.
Yeah.
I was confused.
Then I should pay attention. Can you repeat the question?
Yeah, I saw that when you sort of the directory structure on the Stratum 1 is not like on the file system, is it?
No.
When
Oh,
you
no, it's
access?
object storage. So
Yes.
you're blind. It's all hash
Yeah.
files, but you can connect them back to the actual paths. So if you
Okay.
know which hash files are accessed, there's some tooling that exists already that you can map
Okay.
that back to which files were actually accessed.
Yeah, this I didn't know. Okay. Yeah, then it makes sense.
That's already there. And I think the part that's missing is you could have some more broader tooling that just a tool that you run on the logs of the mirror server or the proxy server, and it just reports you back which files were used and maybe even how often they were pulled in again from, well, then that's mostly for proxy. So if they were pulled in multiple times over a given time window, you could actually tell. So there's tooling to map the hashes to the files, but that's not aware of the structure we have in the Easy repository. So you could take that one step further and have some easy aware tooling to make that analysis better.
Yeah. Okay. Thanks.
There's actually also a parameter, but I think that's a client parameter, which will put the full path to the file that you're accessing into the HTTP header. And that would make it much easier. But of course, that has to be enabled then on the client. If it's not, then you still only get the hashed version of the file.
I guess all those information is like pretty important for you, Eric, right? Since you need to like go through the logs and like auditing them, making sure that nothing wrong is happening, right? So
Yeah. Well, again, I don't think I necessarily need to. Well, maybe if I need to debug and fix, it's interesting to know what files they were trying to access. But in terms of auditing, I haven't thought that layer would be necessary to audit directly what type of files they were accessing. It's just ensuring that well, essentially that they with the read only, that's the primary blocker, that doesn't, nothing happens with that, right? So that nobody actually either tries to write to the system or that they actually could write to the system. That's primarily underlying, I guess, on the Linux server is where those logs would be caught in the system D logs. Is primarily what I've been thinking about when I've been setting this up, but I have not dug very deep into how I'm gonna audit and do the monitorization of the logging yet. But all of these are stuff I will look into.
For the right aspect, as long as you're using a regular CernVMFS client, I don't think the right operation is even implemented in CernVMFS. There's no way they can they can write to that mount. Detecting whether they're trying to write, yeah, that could be interesting. But then it's mostly probably going to be by user mistake rather than
Yeah.
anything else. But fine, yeah, you could
Yeah,
definitely.
yeah, but you can analyze that and look in the patterns to see if this was a mistake or if this was an attack, so to speak.
Any more questions? Doesn't mean it has to be to Eric or the solution. Anything anyone would like to share? Okay, so for now, I will stop the recording in case you prefer to share anything related to EESSI without being recorded.